let's take a look at the questions on homework number 20. So for this first task, when you graph your systems onto this coordinate plane, they both need to be in slope-intercept form, which the first one is. When you're in slope-intercept form, the constant at the end is your y-intercept. So you can plot your first point right there at -3. The coefficient of x is your slope, so that is the change in your y value, which is 3, over the change in your x value, which is 2. So that's a rise of 3 and a run of 2. And once you make your second click, you'll have drawn your line. The second sentence, x plus y equals 7, can be graphed two ways. One is it can be rearranged or manipulated so that the y is isolated, and it is in slope-intercept form, where you start at your y-intercept, and then you follow the slope down 1/1, right? And so we could do that, or we can graph using intercepts. That's where you remove one variable, or you remove the other variable, and you get your two intercepts. They both happen to be 7. So I'm going to use that technique this time. +7 was my y-intercept, +7 was my x-intercept, and there's my second line. This right here is the point of intersection, or the solution to the system, which is the coordinate point 4, 3. So you can use slope-intercept graphing, or you can use x and y intercepts. So the first one is in slope-intercept form. So I'm going to start at -1. I'm going to rise 2, run 1. Now my second one is in standard form. So I'm going to use the intercept method. So my x-intercept is 8. And my y-intercept will be 4. So my x-intercept was 8. So on my x-axis I click 8. But my y-intercept was 4. So my y-intercept I click 4. This is the point of intersection here, which is 2, 3. So those are two possible techniques that you can use to graph, by isolating y in slope-intercept form or using your x and y intercept method. I'm going to take a look here at the second topic, which is context inequality systems graphically. So we're going to translate these systems here so that we can graph them on our coordinate plane below. So it says Savannah is working 2 summer jobs, making $10 per hour washing cars and $22 per hour tutoring. In a given week, she can work at most 8 total hours, and she must earn no less than 110. X represents cars, Y represents tutoring. So write and solve the system. All right, let's back up. X is cars, Y is tutoring. So it's $10 per hour washing car, plus $22 per hour tutoring. And we know that these are money numbers, right? And a reminder that the solution on the other side of either the equal sign or the inequality also has to be a money number. So it says she can earn no less than 110. So she can equal 110, or she can be more, but she can't be less. So there's our first inequality. Our second one is about the hours she works. It says she can work at most 8. She can work less than 8. She can work equal to 8, but she can't work more. And that's all of these hours plus all of those hours. Now what we have over here in red and blue, those are standard form sentences. And in order to graph it, they want it in slope-intercept form. So we're going to have to do some manipulating here. I'm going to manipulate my blue sentence first because it's the easiest. And that would be that y is less than or equal to, I'm going to change this, 8 minus x. So that's my first one. And my second one, when I manipulate it, let's see if I can get this out of the way for a second. My second one, when I manipulate it, is going to be 22y is greater than or equal to 110 minus 10x. And then I'm going to divide everything by 22. All right, let's take a look here. We're going to get 110 divided by 22. It gives me $5, or 5. And then 10 divided by 22. Okay, let's see. I think I'm going to leave this one as a fraction. I'll just reduce it, right? So if I put it in fraction form, and I get 10 over 22, I'm going to change it to 5/11ths. So let's see. Y is greater than or equal to 5 minus, I believe it was 5/11ths, x. All right, let's clear this off. Okay, so my first one is 8 minus x. So if I start at 8 here and I click the plot, oh, it plots it for me. Oh, that was nice. And then this one, let's see, how do I want it shaded? I want it shaded less than, right? So as many times as you click this, it will go back and forth. I want less than, so that's here. And it's going to plot this one for me, and that one is greater than, so it should be going this way. All right, so this double shaded area is the only area that fulfills both of her needs, which is working 8 hours or less and earning $110 or more. So we just need to pick any random point that is within this double shaded region that satisfies both inequalities. So I'm going to go with 1, 6. So 1 is x, and x is washing cars. So she could spend 1 hour washing car, and she could spend 6 hours tutoring. 1 hour, 6. Okay, there we go. Let's give it a try. Awesome. You can read through if you get something incorrect, but you notice that they rewrote their sentences just like we did so that it could be graphed. And they're drawing these little yellow dots. Those are all some of the integer values. Let's try this one more time. All right. Israel went to a bakery. It sells cookies for $1 each and brownies for $2.50. So $1 for cookies. Oops, cookies is x. $1 for cookies. $2.50 for brownies. And they have $20 to spend. So they can't spend more than they've got. So that's a less than or equal to. And they must buy no less than 13. So that means they want more, but not less. And they're buying cookies and brownies. All right, let's alter this one first. It's the easiest one. It's going to be 13 minus x. So 13 minus x. Now I'll erase this one here. Okay. Let's go back. 13 minus x, and that was greater than or equal to, yep. Okay, now for this second sentence, when we modify, we're going to get 2.5 less than or equal to 20 minus x, and then we divide by 2.5. Let's see if I can just write it like that. Let's see if I can write it as one giant fraction. 20, I'm going to make a fraction part now. Minus x over 2.5. Plot each of these. Well, no, I'll plot one at a time. Let me fix this one first down here. It's supposed to be less than. But don't plot it. Oh, it's already plotted. The first one was 13 minus x. So it's this one here, this top one. And it needs to be greater than. So that's this way. And this one is less than, which is this way. Okay, so this is the double shaded region. I'm going to pick any integer point down here. I'm going to pick 14, comma 1. So 14 is the x, and x is cookies. So 14 cookies, 1 brownie. I could even pick 14, 2. I can even pick 14, 2. So I'll do that. 14, 2. Yeah, let's take a look at the third topic. All right, the first sentence will remain the same. The second sentence will modify to become positive 7x, negative 3y, and be careful, negative 25. Once combined, those eliminate. And x is negative 7. I'm going to use that in my first sentence, I guess. Doesn't matter. Both will give us the answer. This is 14. Negative 24. And negative 8. So our solution is negative 7 and negative 8. Negative 7 for x, negative 8 for y, and we'll submit our answer. Let's take a look at the, okay, this one is asking us to solve using substitution. And for substitution, you need an isolated variable, which we have, and that means that you erase and replace. So I'm going to use the second sentence, but I'm going to erase the letter y and replace it with this substitute. Then I'm going to distribute, combine, and use my inverses. Minus 24. Right, I'm going to do this here. I combine these here. And I'm just going to jump ahead here. Let's see, negative 9. So x is negative 1. And now I'm going to go back to this sentence. And I'm going to erase and replace the letter x with its value, which is negative 1. And negative 2 plus 4 is 2. So my values are x is negative 1 and y is 2. Okay. That completes our lesson for homework number 20.